Welcome, my friends, to tonight's Off Science to Sleep By. As you settle into the quiet of the evening, perhaps lying back, ready to rest, let us take a slow and calming dive into one of the most profound mysteries of existence. The question we ask is simple, yet infinitely deep. Can nothingness explode into energy? Together, we'll drift through the realms of physics, cosmology, and philosophy, softly unraveling the story of how something might emerge from nothing. This is not just a question of science. It's a question about reality itself, and how everything you see around you may have begun in silence, in stillness, in a place we might call nothing. Let's begin. When we hear the word nothing, it might feel like the simplest concept in the world. After all, nothing is the absence of something. If you open a box and it's empty, we casually say, there's nothing inside. If a room has no furniture, no people, no sound, we might call it empty, silent, and bare. In everyday language, nothingness seems obvious, but when scientists and philosophers try to pin down exactly what nothing means, the idea becomes slippery, complex, and even paradoxical. As we explore whether nothingness can truly explode into energy, we first have to slow down, quiet our thoughts, and carefully understand what we mean when we talk about nothing. In philosophy, the question of nothingness is ancient. Thinkers for thousands of years have debated whether absolute nothingness can exist, or whether there is always something, even if that something is invisible, intangible, or beyond our senses. For example, the ancient Greek philosopher Parmenides argued that nothing cannot exist at all, because if you can speak about it, or imagine it, then it becomes something. On the other hand, later thinkers wrestled with the opposite idea, that the universe itself must have come from nothing. Because if there was always something, then we are trapped in an infinite loop of asking what came before. These philosophical questions, stretching across centuries, are not just abstract ideas. They set the stage for how modern science approaches the mystery of the universe's origin. When physics entered the conversation, it gave us new tools to think about nothingness, but it also introduced new complications. In science, nothing is not always the same as the common sense meaning of the word. An empty box, for example, is not truly empty. It contains air. And even if you pump out the air with a vacuum pump, there are still invisible molecules, scattered atoms, and background radiation seeping through. In the deepest space between galaxies, where there seems to be utter emptiness, there are still particles, energy fields, and faint whispers of light from the Big Bang. So even what we might call empty space is not truly nothing. In physics, the search for nothing takes us to the idea of the vacuum. A vacuum, in the strictest sense, is space without matter, without particles. But quantum physics reveals that even this kind of emptiness is not truly empty. At the quantum level, space is restless, filled with fluctuations where particles can briefly pop into existence and vanish again. This is sometimes called the quantum vacuum, and it is one of the most profound discoveries of modern science. In other words, when scientists talk about nothing, they often mean something quite different from the everyday idea of pure emptiness. The scientific nothing is more like a quiet background hum of possibilities, a stage upon which the drama of creation can begin. Philosophy, however, keeps reminding us that even this quantum vacuum is still something. It has laws, it has structure, it has energy. So can there be such a thing as true nothingness, a reality with no space, no time, no matter, no energy, no laws, no possibility? Many philosophers argue that such a nothing is unimaginable, because even imagining it requires us to picture it as something, like a blank void, a dark space, or a silent background. But these images are still something. A void is still a kind of space. Darkness is still a state of perception. Silence is still a condition of sound. True nothingness slips away every time we try to capture it in thought. This difficulty shows us why the question of whether nothingness can explode into energy is not just scientific, but also deeply philosophical. Science works with models, with measurable things, with predictions and experiments. But what if the very foundation of existence began with a state we cannot measure, cannot picture, and cannot even fully define? For some thinkers, this is where philosophy and science meet, not in conflict, but in partnership. Science gives us equations, experiments, and discoveries. Philosophy gives us language, concepts, and the courage to ask questions that may have no final answer. One way to understand this is to think about zero in mathematics. The number zero represents nothing, but in reality, it is a powerful concept. With zero, we can do arithmetic, we can balance equations, we can describe symmetry and equilibrium. Zero is not the absence of numbers, but rather a number itself, a placeholder that allows us to describe the difference between presence and absence. Some scientists argue that nothing in the universe might work the same way. It is not the total absence of being, but a condition from which being can emerge, the baseline that makes something possible. If we look at nature, we often find that opposites balance each other. Positive charges and negative charges, matter and antimatter, attraction and repulsion. In this view, perhaps nothingness is not so much an empty void, but a balance point, where all forces cancel each other out, all energies neutralize, and existence hovers at zero. From that balance, a small disturbance might be enough to spark creation. In this way, nothingness would not be a dead silence, but a kind of stillness pregnant with possibility, like a calm ocean surface hiding the potential for waves. Another perspective comes from theology and metaphysics, where nothingness is sometimes linked to creation itself. Different traditions have asked whether a divine force created the universe out of nothing, or whether creation was the shaping of chaos into order. These ideas echo in scientific discussions today, though they are expressed in different language. For example, when scientists talk about the Big Bang as the beginning of space and time, they are essentially saying that before this event, there was no something to measure. But whether this means there was truly nothing remains a mystery. In American culture, and especially for us audience, this question resonates with our sense of curiosity and wonder. The United States has long been a place where science and philosophy intersect in everyday life, whether through the awe of space exploration, the fascination with physics in popular books and shows, or the simple late-night conversations where friends ponder where we came from and why there is something instead of nothing. This makes the concept of nothingness not just an abstract question, but part of a shared human journey, a trying to understand our place in the cosmos. As you reflect on this, it is important to notice how language itself struggles with the concept. Every time we try to describe nothing, we end up describing something: emptiness, void, vacuum, silence. The human mind may not be built to grasp nothingness, because our brains evolved in a world of things: trees, rivers, stars, people, sounds, and colors. We never experience absolute nothingness in daily life. Even in darkness, there is the awareness of seeing nothing. Even in silence, there is the awareness of hearing nothing. Nothingness is always experienced as something. And yet, despite this paradox, we continue to ask the question: can nothingness explode into energy? Can the most silent of all silences give rise to the loudest of all beginnings, the birth of a universe? To approach this question, we must first be comfortable with the strange, elusive, and shifting meanings of the word nothing, and how both science and philosophy guide us toward deeper ways of understanding it. When we think about the vacuum, we might picture a hollow space, a vast emptiness stretching forever, devoid of matter, sound, and light. In popular imagination, the vacuum of outer space is often portrayed as the closest thing we can experience to true nothingness. Yet, the deeper science looks into the vacuum, the less empty it seems. The vacuum is not barren or silent, it is restless, alive with subtle tremors and fluctuations that defy our common sense notions of emptiness. This strange reality, known as the quantum vacuum, challenges our ideas of what it means for space to be empty, and it opens up profound questions about how something as grand as the universe itself could arise from what appears to be nothing. The story begins with quantum mechanics, the branch of physics that governs the smallest scales of reality. In the classical view of the world, Empty space was imagined as a blank canvas, a stage on which particles and forces acted, but which itself was completely featureless. But when quantum theory emerged in the early 20th century, it revealed that the smallest scales of reality behave in ways that are unpredictable, counterintuitive, and astonishing. One of its core principles is uncertainty, the idea that particles do not have definite positions or energies until they are measured, but instead exist in states of probability. This principle also applies to the vacuum itself, which means that even the emptiest possible space cannot remain perfectly still. According to quantum field theory, space is filled with fields, mathematical entities that stretch across all of reality. Particles, such as electrons or photons, are excitations or ripples in these fields. Even if no particles are present, the fields themselves cannot be completely at rest. They quiver and shift in what scientists call quantum fluctuations. These fluctuations cause pairs of particles and antiparticles to appear briefly, borrow energy from the vacuum, and then vanish almost instantly. These ghost-like appearances are often called virtual particles. They do not linger long enough to be directly observed, but their presence leaves measurable effects on the physical world. One of the most famous examples of this is the Casimir effect. If two metal plates are placed extremely close together in a vacuum, they experience a tiny force pushing them together. This force arises not from any visible energy or particles between them, but from the fluctuations of the quantum vacuum itself. The effect has been measured in experiments, confirming that the vacuum is not empty at all but rather a seething ocean of invisible activity. What we once thought of as nothing is, in fact, a bubbling quantum soup. Another striking implication of the quantum vacuum comes from the study of black holes. In the 1970s, the physicist Stephen Hawking discovered that black holes are not completely black. Instead, due to quantum fluctuations near their event horizons, black holes can emit radiation. This so-called Hawking radiation arises because virtual particle pairs form near the edge of the black hole. Normally, these pairs annihilate one another and disappear. But if one particle falls into the black hole while the other escapes, the black hole slowly loses mass, and radiation is emitted into space. This groundbreaking insight revealed that the quantum vacuum is not only active, but can also give rise to phenomena that reshape our understanding of the cosmos. For many scientists, this realization changes the way we think about nothingness itself. The quantum vacuum is not an absence of reality, but a foundation of potential. It is a field of latent energy, a fertile ground where particles can emerge and dissolve, where forces can ripple, and where the seeds of creation may lie hidden. In this sense, the quantum vacuum blurs the line between nothing and something, suggesting that the boundary may not exist at all. The idea that the vacuum is filled with energy has profound consequences for cosmology. Physicists now believe that the expansion of the universe itself is driven, in part, by the energy of empty space, known as dark energy. This mysterious force, which makes up about 70% of the universe, is accelerating cosmic expansion. Though its nature remains unknown, it may be linked to the same vacuum energy that quantum theory predicts. If this is true, then the ultimate fate of the universe could be tied to the very properties of what we once thought of as nothing. For us audience familiar with space exploration and the cultural fascination with the cosmos, this concept is especially compelling. From the iconic images of astronauts floating in space to the breathtaking views of distant galaxies captured by telescopes, the vacuum has always been a symbol of emptiness. Yet science tells us that this emptiness is anything but silent. It is an invisible engine that shapes the universe on every scale, from the smallest particles to the grandest cosmic structures. The vacuum is not a void but a hidden architect of reality. This redefinition of nothingness also pushes us into philosophical territory. If the vacuum is full of activity, then can it really be called nothing? If fluctuations generate particles, if invisible forces create measurable effects, if the vacuum itself has energy, then perhaps the idea of true emptiness is an illusion. What we call nothing may simply be the lowest energy state of reality, a background that always contains the possibility of something. In this way, the quantum vacuum becomes a bridge between physics and metaphysics, suggesting that creation may not require an external cause, but may arise naturally from the restless fabric of existence. The strange behavior of the quantum vacuum is not just a curiosity, it is essential to understanding why the universe exists in the form we see today. In the early universe, when everything was compressed into an unimaginably small and hot state, quantum fluctuations may have played a decisive role. These fluctuations could have been magnified during a phase of rapid expansion called cosmic inflation, seeding the tiny differences in density that later grew into galaxies, stars, and planets. Without the fluctuations of the vacuum, the universe might have remained smooth and featureless, a sea of uniform energy with no structure, no matter, and no life. The very diversity and richness of the cosmos may trace back to the restless activity of what we once thought of as nothing. Even in everyday life, the influence of the quantum vacuum is all around us. The light from your lamp, the functioning of electronic devices, the chemistry of atoms, all are shaped by quantum principles that include the fluctuations of empty space. Every photon of light that travels across the room is an excitation of a field that would exist even if no particles were present. Every atom in your body is stabilized by principles that depend on the uncertainty of quantum mechanics. In this sense, you yourself are a living testament to the power of a seething vacuum. And yet, despite its central role, the quantum vacuum remains mysterious. Physicists still struggle to calculate its energy with precision, and current estimates produce results that are staggeringly larger than what we observe in the universe. This mismatch, known as the cosmological constant problem, is one of the greatest unsolved puzzles in physics. It suggests that our understanding of the vacuum is incomplete, and that deeper theories, perhaps involving string theory, multiverses, or as yet unimagined frameworks, may be needed to resolve the paradox. The very existence of such mysteries reminds us that science is not a closed book, but a continuing story. The vacuum, once dismissed as a barren void, has become a central character in this story, whispering secrets about the origins of matter, the fate of black holes, and the destiny of the cosmos. For those listening tonight, this realization can be both humbling and comforting. It tells us that even in stillness, even in silence, even in what we imagine as emptiness, there is a hidden vitality, a constant motion that ensures the universe is never truly at rest. To truly explore whether nothingness can explode into energy, we must now step into one of the most intriguing concepts in modern physics: spontaneous creation. At first, the phrase itself sounds almost magical, something emerging out of nowhere, without cause, without plan, without an outside agent to push it into motion. In everyday life, we never witness this. A tree grows from a seed. A fire ignites from a spark. A song begins with a breath. Everything we see seems to require something else to set it in motion. But on the quantum scale, in the tiny world where particles flicker in and out of existence, reality plays by different rules. Spontaneous creation suggests that particles, energy, even the seeds of entire universes might arise without any external trigger, springing from the restless properties of nothing itself. The foundation of this idea lies in the principle of quantum uncertainty. According to Heisenberg's uncertainty principle, there is a fundamental limit to how precisely we can know a particle's position and momentum at the same time. This principle doesn't just apply to particles we can see, it extends to the very fabric of space. In practical terms, it means that the energy of empty space cannot be exactly zero. Even in its lowest energy state, space trembles with uncertainty. From this trembling, pairs of virtual particles can momentarily appear. They live for the briefest of instants, borrowing energy from the vacuum, before annihilating one another and disappearing back into the background. These ephemeral appearances are not rare events, they are happening constantly, everywhere, filling space with the ceaseless dance of creation and destruction. The idea that the universe itself could emerge from spontaneous creation builds on this quantum behavior. If tiny particles can arise from fluctuations, what prevents larger and larger structures from doing the same, given the right conditions? Some physicists propose that the Big Bang, the event that marks the beginning of our observable universe, could have been a spontaneous creation event. In this view, space, time, matter, and energy all emerged from a quantum fluctuation of an earlier state, perhaps a vacuum, perhaps something even more fundamental. The universe may not need a cause beyond itself. It may be that existence is possible simply because non-existence is unstable, and nothingness naturally gives birth to something. This is a radical shift from the way humans have historically thought about beginnings. For thousands of years, cultures around the world have imagined creation as an act requiring a creator, whether a divine being shaping the cosmos or a cosmic event triggered by forces outside the universe. Spontaneous creation challenges this intuition. It suggests that the universe can be self-contained, with no external spark. The laws of physics themselves could be enough to generate reality, not once, but perhaps countless times. If spontaneous creation is possible, then our universe may not be unique. There may be many universes, perhaps infinitely many, each bubbling into existence from the quantum foam of nothingness. For an audience listening in the stillness of night, this can be both bewildering and strangely soothing. Imagine lying in a quiet room, the hum of the day fading away, and realizing that the silence around you is not truly empty. On scales far smaller than your eyes can see, space itself is alive with invisible activity. The particles that make up your body, the atoms in your breath, the energy in your thoughts, all have their roots in a universe that may have emerged from nothing without cause. It is a reminder that creation does not always require a push. Sometimes, existence is the natural state of reality, a spontaneous flowering that cannot help but arise. One of the most fascinating aspects of spontaneous creation is its connection to energy balance. Physicists have pointed out that the total energy of the universe may actually be zero. The positive energy of matter and radiation may be perfectly balanced by the negative energy of gravity. In this delicate balance, the net cost of creating a universe could be zero. If so, then spontaneous creation is not only possible, but natural. The universe could emerge like a perfectly balanced equation, requiring no input from outside, no borrowing from a greater source, no spark of divine intervention. This perspective does not diminish the wonder of creation, but deepens it. It suggests that the very structure of reality is such that existence is inevitable. To appreciate this, think of a still pond. On its surface, everything appears calm, unmoving, but beneath that calm, molecules are vibrating, shifting, colliding. Every so often, without any obvious cause, a ripple might form. It is not created by a thrown stone or a gust of wind, but by the restless energy of the system itself. Spontaneous creation in the universe may be similar. What appears as silence and stillness is never truly motionless. Beneath the calm of nothingness, fluctuations stir, and from those fluctuations, reality can emerge. Another analogy comes from the world of chemistry. Certain reactions happen spontaneously once the conditions are right, without the need for an external catalyst. They are driven not by outside forces, but by the inherent properties of the molecules involved. Spontaneous creation at the cosmic level may work the same way. When the conditions of the quantum vacuum align, the natural laws allow for the birth of particles, fields, and even universes. It is not magic, but the unfolding of possibility built into the fabric of reality itself. Yet, the idea of spontaneous creation raises deep philosophical questions. If universes can emerge spontaneously, does that mean there is no need for a cause, no need for an answer to why there is something rather than nothing? Or does it mean that the laws of physics themselves, which allow for spontaneous creation, demand an explanation? Where do those laws come from, and why do they exist at all? For some, spontaneous creation removes the need for any deeper cause, showing that the universe is self-sufficient. For others, it only pushes the question back a step, inviting us to ask why the conditions for spontaneous creation exist in the first place. For us audience, immersed in a culture that often blends curiosity, science, and philosophical wonder, These questions resonate with both scientific discovery and personal reflection. The idea that the universe may not require a creator, that it may have sprung forth on its own, challenges traditional narratives, but also empowers a vision of a cosmos that is deeply elegant, self-contained, and mysterious. In this way, spontaneous creation is not just a theory about the past, it is an invitation to reflect on the very nature of existence. The more we study the cosmos, the more evidence we find that supports the role of spontaneous creation in shaping reality. The structure of galaxies, the distribution of cosmic background radiation, the very existence of matter over antimatter all may trace their origins to fluctuations and spontaneous events in the early universe. Far from being rare or improbable, spontaneity may be woven into the fabric of creation itself. It may be that the reason we are here, the reason anything exists at all, is because nothingness could not hold still. It wavered, it fluctuated, it created. And from that spontaneous act, a universe was born, filled with stars, planets, and eventually, the quiet moment you are experiencing now, listening, wondering, and resting in the mystery of it all. When we look up at the night sky, gazing at the vast dome of stars scattered across the darkness, it is natural to wonder how it all began. The galaxies, the planets, the clouds of dust and gas, the very light that travels across billions of years to reach our eyes, all of it must have come from somewhere. In modern science, the leading explanation for the origin of the universe is the Big Bang. But what exactly was this event? Was it truly an explosion, as the name suggests? And more importantly for our journey tonight, was it a burst from absolute nothingness? The story of the Big Bang begins with discovery, not theory. In the 1920s, astronomer Edwin Hubble observed that distant galaxies were moving away from us, their light stretched to longer, redder wavelengths. This effect, known as redshift, revealed that the universe is not static, but expanding. If everything is moving apart now, it follows that in the past, everything must have been closer together. If we trace this expansion backward, we arrive at a time when all the matter and energy of the cosmos were compressed into an incredibly dense, hot state. This realization gave rise to the Big Bang theory, which proposes that the universe began around 13.8 billion years ago in a moment of rapid expansion from an unimaginably small and energetic point. The word bang is a little misleading. The Big Bang was not an explosion in space. It was an expansion of space itself. In an explosion, matter blasts outward into empty surroundings. But in the Big Bang, there was no surrounding space to expand into. Space and time themselves were born in that moment. The Big Bang was not something that happened at a point in space. It was the simultaneous creation of space everywhere. Every atom, every galaxy, every star we see today emerged from that single beginning. For many, the question that immediately follows is, what came before? If the universe expanded from a singular point, what existed before that point? Here, science meets its limits. According to our best understanding, time itself began with the Big Bang. The very concepts of before and after may not apply. Asking what came before the Big Bang may be like asking what is north of the North Pole. It is a question that breaks down under its own terms. This does not mean the question is meaningless, only that our current language and ideas struggle to capture the reality of such an event. But does the Big Bang mean the universe arose from nothing? This is where the mystery deepens. On one hand, the Big Bang appears to be the ultimate example of something coming from nothing, the sudden appearance of space, time, matter, and energy where there was none before. On the other hand, physicists caution that the universe may not have come from absolute nothingness, but rather from a state governed by laws we do not yet fully understand. Some propose that the universe emerged from quantum fluctuations in a vacuum, as we discussed earlier. Others suggest that the Big Bang was not the beginning at all, but a transition from an earlier state, such as a collapsing universe that gave birth to a new one. The idea that the Big Bang could have arisen from a quantum fluctuation is particularly fascinating. In this view, what we call nothing was actually a quantum vacuum, seething with potential. A fluctuation in this vacuum may have caused a rapid inflation of space, creating the conditions for matter and energy to form. This process would not require an outside cause. Instead, the laws of physics themselves, acting on the restless vacuum, would be sufficient to spark a universe. In this sense, the Big Bang might not have been an explosion out of absolute emptiness, but a natural unfolding of possibilities that were already present in the fabric of reality. For those lying quietly tonight, letting the rhythm of thought guide them toward rest, it is worth pausing on the strangeness of this idea. Imagine absolute silence suddenly filled with sound, not because anyone struck a note, but because silence itself could not hold. Imagine darkness suddenly filled with light, not because a switch was flipped, but because darkness itself had within it the seeds of illumination. The Big Bang, as we understand it, may have been such a transformation, where what appeared as nothing gave way to everything, not by force, but by the natural laws of existence. Another perspective considers energy conservation. As mentioned earlier, the total energy of the universe may be exactly zero, with the positive energy of matter balanced by the negative energy of gravity. If this is true, then the creation of the universe would not have required an input of energy from outside. It would have been a balanced transaction, a zero-cost event. The Big Bang, in this sense, would not violate any physical principle, but would instead represent the perfect symmetry of creation from nothing. Yet, the Big Bang also raises profound questions that remain unanswered. Why did the universe expand the way it did? Why did matter form instead of antimatter dominating? Why did the laws of physics take the form they do? Some scientists suggest that multiple universes may exist, each with different laws, and we happen to live in one where conditions allowed galaxies, stars, and life to form. In this multiverse scenario, the Big Bang was not a singular beginning but one of countless spontaneous events. If so, then our universe is one bubble in an endless cosmic foam, each bubble a burst of creation from nothing. For us audience, where the fascination with cosmic origins often mixes with cultural and spiritual reflection, the Big Bang holds a unique place. It is both a scientific theory supported by overwhelming evidence and a story that resonates with ancient human longing to understand beginnings. Americans have long looked to the stars as symbols of possibility, from the frontier spirit to space exploration. To imagine that all of it, the Earth, the Sun, the Milky Way, sprang from a single cosmic event is both humbling and inspiring. It places our lives in the context of a story that stretches across billions of years, beginning in a burst so profound that even now, its echoes ripple across the cosmos. Those echoes are real. The cosmic microwave background radiation, discovered in the 1960s, is the faint afterglow of the Big Bang. It fills space in every direction, a soft whisper of the universe's fiery birth. To this day, it provides a map of the infant cosmos, showing the tiny fluctuations that later grew into galaxies. When we detect this background radiation, we are not just observing data, we are listening to the memory of creation, the lingering light from the moment when the universe itself was young. And so, when we ask if the Big Bang was a burst from nothing, the answer is layered. From one perspective, it was the beginning of space, time, and matter, and thus a true emergence from nothing as we understand it. From another perspective, it was not absolute nothingness, but a transformation of a quantum state we do not yet fully comprehend. In either case, the Big Bang represents the profound mystery of creation, the point at which all we know and all we are came into being. When we think about energy, we often picture something active and visible, the warmth of the sun on our skin, the glow of a light bulb in the dark, the fuel that powers cars, or the electricity that hums through our homes. Energy feels like something solid and tangible, something we can measure, harness, and use. But when we zoom out to the scale of the entire cosmos, energy takes on a far more subtle and mysterious role. At the largest scales of existence, the laws of physics suggest that the universe itself may be perfectly balanced, with the total amount of energy adding up to nothing at all. This possibility that all the stars, galaxies, and living beings are the result of a cosmic equation that, Balances perfectly to zero opens a profound doorway into understanding how the universe might have come into existence without violating any principles of conservation. To begin, let's revisit the principle of energy conservation. In physics, this is one of the most fundamental laws. Energy cannot be created or destroyed, only transformed from one form into another. When a ball rolls down a hill, potential energy is converted into kinetic energy. When you light a match, chemical energy is transformed into heat and light. Even when energy seems to vanish, it is not gone, it has simply changed form. This principle has been tested in countless experiments and holds as one of the bedrock truths of science. But how does this law apply to the universe itself? If the universe began with the Big Bang, where did the energy for such an immense event come from? Did it violate the law of conservation? Or is there a deeper balance at play? Here is where modern cosmology offers a surprising and elegant answer. The total energy of the universe may be exactly 0.t first. This sounds impossible. After all, when we look at the universe, we see overwhelming amounts of energy. The sun alone emits more energy in a single second than humanity has used in its entire history. Multiply that by billions of stars across billions of galaxies, and the total seems unimaginably large. And yet, there is another side of the equation that balances this immense energy. The energy of gravity. Gravity, unlike other forms of energy, negative. This is because gravity works by pulling things together, reducing the system's total energy when objects move closer. For example, if you lift a rock into the air, you give it positive potential energy. When you let it fall, that energy decreases as it converts into motion. On a cosmic scale, every bit of matter in the universe is bound by the gravitational pull of every other bit of matter. The energy of this gravitational attraction is negative, and when added up across the entire universe, it appears to balance the positive energy of all matter and radiation. This balance leads to a startling conclusion. The net energy of the universe could be zero. The positive and the negative cancel perfect, like the sum of a debt and a payment. In this view, the universe could have arisen from nothing without breaking any laws, because its total energy is still nothing. The universe would be like a cosmic scale in perfect equilibrium, where the weights on both sides balance exactly, even though the contents are enormous. To picture this. Imagine writing down the number 10 and the number -10. Each has value, each is meaningful, but together they add up to zero. The universe might be the same way, filled with positive energy in the form of matter, light, and motion, balanced by negative energy in the form of gravity. The result is not a contradiction, but a harmonious zero. A universe born not from borrowing energy, but from balancing it. For those listening quietly tonight, perhaps ready to drift toward rest, this idea carries a kind of calming symmetry. Everything we see, the galaxies scattered across the sky, the earth beneath us, the atoms in our bodies, may exist within a perfect cosmic balance. Existence, instead of breaking rules, may be the ultimate expression of harmony. Creation, instead of demanding an outside source, may arise naturally from the possibility of balance. In this sense, the universe itself is like a perfectly tuned instrument, resonating in a state where everything adds up to nothing. This idea is not just poetic, it is supported by observations and theories in cosmology. The concept of inflation, a rapid expansion of the universe in its earliest moments, relies in part on the ability of quantum fluctuations to generate energy while still maintaining overall balance. Inflation theory suggests that a tiny patch of space, governed by quantum laws, could expand exponentially, giving rise to all the matter and energy we see today. Because the positive and negative energies balance, no external input is required. The universe is not stealing from a greater source. It is playing within the rules of its own structure. Some physicists, such as the late Stephen Hawking, embrace this view. Hawking argued that the laws of physics themselves may be sufficient to explain the origin of the universe. If the net energy is zero, and the laws allow for quantum fluctuations, then universes can arise spontaneously, without the need for anything beyond the natural framework of existence. In this view, nothingness is not an obstacle to creation, but the very condition that allows creation to happen. Of course, this raises deeper questions. If the universe balances to zero, why is there a universe at all? Why does balance express itself in the form of galaxies, stars, and life, rather than remaining in perfect silence? Here, science may not yet have a complete answer, but the concept of balance provides a framework for understanding how creation is possible without contradiction. It shows that nothingness and somethingness may not be opposites, but two sides of the same reality. For an American audience, this idea of balance resonates deeply. It echoes themes found in culture and philosophy: the balance of justice, the equilibrium of nature, the harmony of opposites. In the American spirit of exploration, there is often a search for order in the midst of chaos, for meaning in the midst of uncertainty. To discover that the entire universe may be a grand balance, a cosmic equation where all forces cancel, is both scientifically profound and emotionally resonant. Think for a moment about how this balance plays out in your own life. Every breath you take is an exchange of energy, balancing oxygen and carbon dioxide. Every movement is a transfer of energy, from muscles to motion. Even in sleep, your body balances energy, restoring what was spent during the day. In this way, the principle of conservation is not just a law of physics, it is woven into the rhythm of existence. The universe itself follows the same rule, balancing its vast energies to maintain harmony. Another way to visualize this is to imagine the universe as a ledger book. On one side are credits, the positive energies of matter, light, and motion. On the other side are debits, the negative energies of gravity and binding forces. The sum, when carefully calculated, may be zero. This does not mean that nothing exists, it means that everything exists in balance. From the perspective of the ledger, creation does not add cost. It is a transaction that balances perfectly, leaving the books closed and complete. This insight reshapes how we think about nothingness itself. If the total energy of the universe is zero, then the boundary between nothing and something becomes blurred. Nothingness, in this sense, is not a void that resists creation, but a balance that naturally allows it. Something can arise from nothing not by breaking rules, but by fulfilling them. The universe, in all its vastness, may be the grandest example of balance ever conceived. And so, as you rest tonight, listening to the quiet unfolding of these ideas, consider the possibility that you too are part of this balance. Your body, your mind, your very existence are woven into the same fabric that balances stars and galaxies. You are not separate from the equation, you are one of its terms, one of its beautiful expressions. The energy that makes you who you are is balanced by the gravity that holds the cosmos together. In that balance, the mystery of creation continues, and the harmony of the universe sings softly, even in silence. When we ask if nothingness can explode into energy, one of the deepest questions we face is about the very stage on which the universe plays its drama. Space and time themselves. We are so accustomed to thinking of space as the empty backdrop where events unfold, and time as the steady ticking clock that measures those events, that we rarely stop to wonder whether these things are fundamental, or whether they, too, had a beginning. Yet modern cosmology, supported by both theory and observation, suggests that space and time themselves are not eternal, but emergent. They arose with the universe, and without the universe, they may not exist at all. Imagine, for a moment, floating in a vast emptiness. No stars, no galaxies, no earth beneath your feet, only darkness. This seems like a picture of nothing, but in fact, it is not nothing at all. Because there is still a place, the space in which you float, and there is still a duration, the time you experience as you imagine yourself drifting. This is why physicists say that our everyday idea of nothingness is not the same as the nothingness they mean when they talk about the origin of the cosmos. For true nothingness, in the deepest scientific sense, would mean not just the absence of matter and energy, but also the absence of space and time themselves. It would mean no where and no when, no arena in which anything could take place. This is a difficult idea to grasp because our minds are so rooted in the framework of space and time. Every experience we have is framed by where it happens and when it happens. But the Big Bang Theory suggests that before the birth of the universe, these dimensions did not exist. The Big Bang was not an explosion in space. It was an explosion of space. The universe did not begin at a point in space and expand outward into emptiness. It was space itself that expanded, and time itself that began. Asking what was before the Big Bang may not even be a meaningful question, because before implies time, and time itself only came into being at that first moment. This is where the mystery of nothingness deepens. If there was no time, how could anything happen? If there was no space, how could anything exist? These questions stretch our imagination to its limits, because they force us to confront the possibility that reality does not conform to our everyday intuitions. Yet physics offers a way to think about this. The laws of quantum mechanics, which govern the smallest scales of reality, allow for fluctuations that can momentarily create pairs of particles out of nothing. These fluctuations do not need a pre-existing space in the way we imagine, because in quantum theory, space-time itself may be emergent, a phenomenon that arises from deeper, more fundamental rules. Some theories in modern physics, such as quantum gravity and string theory, suggest that space and time might not be the ultimate ingredients of reality. Instead, they may be like patterns that emerge from something more basic, something we do not yet fully understand. Just as temperature is not a fundamental thing, but an emergent property of countless moving atoms, space and time may be emergent properties of more fundamental relationships. In this view, what we perceive as nothingness could itself be a kind of quantum foam, a seething field of possibilities from which both space and time can crystallize. For those lying quietly in the evening, listening and perhaps drifting toward rest, this idea can be strangely comforting. If space and time themselves are not eternal, if they are not the fixed and unchanging background we once thought they were, then nothingness is not just a void, it is a fertile silence, a stillness that contains the potential for everything. The universe, with its galaxies and stars, with its flowing time and expanding space, may be like a wave rising out of a deep ocean of possibility. That ocean is not empty, but it has no form, no dimensions, no clock ticking within it. It is a kind of nothingness beyond our imagination, yet from it, everything we know has emerged. The American philosopher William James once said that our experience of reality is a stream of consciousness. In physics, we might extend this metaphor to space and time themselves. They are the stream in which events float. But before the stream begins, there is no current, no flow, no riverbed. The birth of the universe was the birth of the river itself. The Big Bang was not an explosion within time, it was the beginning of time. And so, when we ask what caused the universe, we must be careful, because cause and effect themselves rely on time. To cause something is to make it happen later, but if time itself had no earlier, the question may need to be reframed. For many cosmologists, this is not discouraging but inspiring. It pushes us to rethink our assumptions about reality. Instead of asking what happened before, we might ask how time itself could emerge. Instead of picturing space as a stage waiting for actors, we might picture the stage itself being woven out of the play. Space and time are not passive, they are dynamic, flexible, and most importantly, they are part of the story of creation. One way to visualize this is to imagine a snow globe. Shake it, and the flakes swirl in space. But the globe itself, the space in which the flakes move, came into being with the very first shake. Space and time are like that globe. They are not containers waiting to be filled, but are themselves born with the contents. The Big Bang was not something that happened in time. It was the moment time itself unfolded. As strange as this sounds, it also connects with our daily experience. Think about how your perception of time changes depending on your state of mind. A joyful moment passes quickly, while waiting in line can feel endless. Time is not a fixed, rigid thing. It bends and stretches in our experience. Einstein's theory of relativity shows that time also bends and stretches physically, depending on speed and gravity. Clocks run differently on airplanes and in valleys than they do on mountaintops. This flexibility hints at the deeper truth. Time is not absolute, and space is not absolute. They are dynamic and interconnected, part of a larger fabric that itself can emerge from nothingness. So, when we talk about nothingness giving rise to energy, we must also talk about the birth of the stage itself. Without space, there is no out there. Without time, there is no back then. And yet, here we are in a universe where space stretches and time flows, where galaxies drift and stars burn. The miracle is not just that something arose from nothing, but that the very possibility of something arose from the silence of no space and no time. As you breathe slowly and let your thoughts settle, imagine this: the moment you call now, this very heartbeat of existence, rests upon a foundation that once did not exist. The flow of time you feel, the space that holds the earth, the sky, and the stars, all of it blossomed from a reality we can barely conceive. Nothingness was not empty. It was the womb of time and the seed of space. And from that, the universe bloomed, carrying us along its unfolding story. When scientists ask whether nothingness can explode into energy, they often focus on equations, theories, and physical laws. But this question also reaches far beyond the boundaries of science, into the territory of philosophy, where humans for thousands of years have wrestled with the most fundamental question of all. Why is there something rather than nothing? This question may sound abstract, but it touches on everything we know, everything we are, and everything we experience. To lie awake at night and wonder why the universe exists at all is to participate in one of the deepest traditions of human thought. In our daily lives, we take existence for granted. We wake up, we move through space and time, we speak, we eat, we breathe. Existence feels obvious, like a backdrop. We do not need to question. But when you pause, when you imagine the possibility of absolute nothingness, no space, no time, no matter, no mind, the strangeness of existence comes into sharp focus. Why should anything exist, rather than nothing at all? The fact that the universe is here, that we are here, feels like a miracle without explanation. Philosophers have approached this mystery in many ways. Ancient Greek thinkers like Parmenides argued that nothingness could not exist, because to speak of nothing is already to speak of something. For him, existence was eternal and changing, and absolute. Others, like Aristotle, saw change and motion as evidence that the universe must have some first cause, something that set everything into motion without itself being caused. Centuries later, in the modern era, philosophers and theologians debated whether God was that uncaused cause, the necessary being whose existence made possible all contingent beings. But science has changed the landscape of this debate. With the rise of cosmology, physics, and quantum theory, we now ask whether the laws of nature themselves can explain the emergence of existence. If the total energy of the universe is zero, as we explored earlier, and if quantum fluctuations can give rise to matter and radiation, then perhaps the universe simply is, without needing an external cause. Stephen Hawking once suggested that the laws of physics are enough to explain why the universe exists. Given the law of gravity, the universe can and will create itself from nothing. Yet even this answer invites more questions. If the universe arose from the laws of physics, where did those laws come from? Are they eternal truths, existing beyond the universe itself? Or are they descriptive rules that only make sense once the universe already exists? If we say the laws came first, then we are not dealing with nothingness at all, but with a kind of hidden order beneath reality. If we say the laws arose with the universe, then how do we explain their emergence from the void? In either case, we find ourselves circling back to the mystery. Why should there be laws, order, or possibility, instead of absolute emptiness? This is where philosophy helps us to sit with questions science cannot fully resolve. Perhaps the very idea of nothing is flawed. When we imagine nothing, we often picture an empty black space. But blackness is something. Space is something. Emptiness is something. True nothingness may not even be conceivable to the human mind. It might be a logical impossibility, as Parmenides claimed long ago. In that case, the fact that something exists is not surprising at all, it is inevitable. Because nothingness could never be real. On the other hand, some philosophers argue that existence itself is deeply contingent, that it could just as easily not have been. For them, the question of why something rather than nothing is unavoidable. They look for explanations beyond physical science, turning to metaphysics, theology, or even the possibility that existence has no explanation at all, that it simply is a brute fact without reason. For listeners drifting into a calm state tonight, it is worth reflecting on how this question feels as much as what it means. To contemplate why anything exists at all is to encounter a profound mystery, one that humbles the mind and opens the heart. It reminds us that we live in a reality that is not guaranteed, not trivial, but astonishing. Even the simplest thing, the warmth of your breath, the weight of your body resting, the sound of your own heartbeat, becomes remarkable when set against the possibility of nothingness. In American philosophy, this question has also found resonance. Thinkers like William James and Charles Sanders Peirce emphasize the role of chance, novelty, and possibility in the unfolding of reality. For them, existence was not a static fact, but a living, dynamic process, always creating and becoming. To ask why there is something rather than nothing is to ask why creativity itself exists, why the universe has the power to generate novelty and life. In this way, the mystery of existence is not just about origins, but about the ongoing process of being. Modern physics has added another layer to the puzzle. Some scientists propose that our universe may not be unique, but one of many, part of a vast multiverse where different universes bubble into being, each with its own laws and constants. In such a picture, our universe exists not because it had to, but because it could. If there are infinitely many possibilities, then some universe was bound to exist, and we find ourselves in one of them. But even this does not escape the philosophical question: why should the multiverse exist? Why should possibility itself exist? Why should there be a canvas for creation at all? This is where science and philosophy intertwine, and where bedtime reflections become both soothing and expansive. The questions are larger than answers, and that is part of their beauty. To dwell on why something exists rather than nothing is not to seek a final solution, but to feel the wonder of existence itself. In the quiet of the night, when distractions fade and the mind turns inward, such reflections can offer peace. The mystery of existence is not a problem to be solved, but a truth to be lived with. A gentle reminder that life itself is a gift without clear explanation. As you rest, consider the possibility that the mystery is itself the answer. Perhaps the universe exists because it can, because existence is the natural state, because nothingness is unstable or impossible, or perhaps there is no reason at all, only the simple and undeniable fact that something is. You are here, the universe is here, and that is enough. In the end, the question, why is there something rather than nothing, may not yield a single satisfying explanation, but the act of asking it connects us to the deepest layers of human curiosity and wonder. It is a reminder that even in the vast silence of the cosmos, our minds reach outward, searching, imagining, marveling. This reaching is not futile, it is what makes us human. To ponder existence is to participate in the universe's own unfolding mystery. It is to recognize that we are not separate from the question, but part of it. We are the something that exists instead of nothing, and in that realization lies both humility and comfort. The night sky above, the stillness around you, and the beating of your heart within you are all testaments to the fact that something is. And that is a truth worth resting in. When we arrive at the question of nothingness and energy, of beginnings and existence, we eventually find ourselves at the edge of what we can know. Science gives us remarkable tools, equations, telescopes, experiments, theories that reach back to the very first moments of the universe. Philosophy gives us the language to ask deeper questions about why there is something rather than nothing. Yet no matter how far we travel into these realms, the horizon always expands beyond our reach. There is always another mystery waiting, another layer of wonder, another question that remains unanswered. And in that recognition, at the place where our knowledge falls away, there is comfort. For some, the unknown can feel unsettling. We like answers, closure, certainty. But when we turn to the cosmos, the mysteries are vast and enduring. No one can say with absolute clarity why the universe exists, or what nothingness truly is, or whether there could have been a different reality than the one we inhabit. Yet this uncertainty does not need to be frightening. It can be soothing, because it reminds us that existence is bigger than us, bigger than our struggles, bigger than any single explanation. The mysteries are not gaps to be feared, but invitations to wonder, spaces where the imagination can drift freely. Like clouds across a quiet night sky, think for a moment of how you feel when you gaze at the stars. You cannot name every star, nor trace every galaxy, nor calculate every orbit. Yet the act of looking up fills you with awe. The unknown does not diminish the beauty of the sky, it magnifies it. The fact that we cannot fully comprehend the universe is not a weakness, but a source of endless richness. If everything were explained, catalogued, and solved, the cosmos might lose some of its magic. But because mystery remains, we are always connected to something greater than ourselves. This is why embracing mystery brings comfort. It allows us to rest in the knowledge that we do not need all the answers to be at peace. We can let go of the demand for certainty and allow ourselves to simply be part of the unfolding story. Just as a child falls asleep while listening to a lullaby, not needing to understand every note, we too can rest in the lullaby of the universe, knowing that its music is larger than our comprehension. Science itself carries this comfort, because it shows us that mystery is not the absence of understanding, but the very heart of discovery. The greatest advances have always come from questions that seemed impossible. What is light? What are the stars made of? How old is the earth? Each mystery, once probed, revealed deeper layers of reality, and behind those layers, more questions. The fact that there will always be questions means that the universe will always hold us in a state of wonder. Even as we sleep tonight, galaxies are moving, stars are being born, black holes are shaping the fabric of space-time. All of this happens far beyond our control, and yet, we belong to it, we are made from it, we are carried by it. There is also comfort in knowing that mystery connects us across time and culture. Ancient peoples looked at the sky with awe, just as we do. They created myths, stories, and philosophies to explain the great questions. Today, we turn to physics and cosmology, but the sense of wonder is the same. To ask about nothingness and energy is to join a human tradition as old as thought itself. You are not alone in your wondering. You are part of a lineage of seekers, dreamers, and thinkers who have all felt the same stirring in their hearts. In American culture, there is often a spirit of exploration, of pushing boundaries, of venturing into the unknown. From crossing frontiers to reaching into space, this spirit thrives on mystery. And yet, exploration is never only about reaching the end of the path, it is also about the journey itself, the sense of being in motion, of being alive in the face of the vast unknown. The same is true of cosmic mystery. We do not need to arrive at final answers to find meaning. The very act of questioning gives life its depth and beauty. Consider, too, how mystery plays out in your own life. Each day unfolds in ways you cannot fully predict. Each dream you have at night arises from unknown depths of your mind. Each relationship, each choice, each moment contains uncertainty. Yet life flows on, not despite the unknown, but because of it. The mystery of existence is not just out there in the stars, it is here, in your breathing, your thoughts, your heartbeat. To rest in mystery is to rest in the reality of being alive. So, when we return to the great question, can nothingness explode into energy? We may find comfort not in the answer, but in the fact that the question itself exists. It shows that we are beings capable of wonder, that our minds stretch toward the infinite, even as our bodies rest in the finite. It shows that the universe is not a solved puzzle, but a living mystery, unfolding moment by moment, inviting us to gaze, to listen, to dream. As you settle into rest tonight, let this comfort wash over you. The mystery of the universe is not a weight to bear, but a gentle blanket, wrapping you in the knowledge that you are part of something vast, timeless, and beautiful. You do not need to solve the cosmos to belong to it. We began with the question that sounds impossibly large: can nothingness explode into energy? Along the way, we discovered that the word nothing itself is slippery, changing shape depending on whether it is used in philosophy, in physics, or in our own imagination. For philosophers, nothingness might mean the absence of all being, a concept so pure it may not even be thinkable. For physicists, nothingness is more often a fertile field, a quantum vacuum humming with unseen fluctuations, always ready to spark with possibility. We explored how the vacuum of space, far from being empty, is alive with potential, filled with virtual particles that blink in and out of existence. These tiny fluctuations, though invisible, may hold the seeds of everything. Then we asked whether the Big Bang itself could have been such a fluctuation on the grandest scale, a moment where the laws of physics allowed something vast to emerge from what seems like nothing. We also turned to energy itself, that constant companion of existence, and found that the entire universe may be a perfect balance. Matter and radiation give us positive energy, but gravity contributes its own negative energy. Together, the two may cancel to zero, suggesting that the universe as a whole adds up to nothing. In that sense, the creation of the cosmos may not have broken any laws. It may have flowed naturally from the harmony of balance. But creation was not only about energy. We saw how space and time themselves, the very framework in which we think and live, are not eternal backdrops. They were born with the universe, expanding and flowing from that first moment. To speak of before the Big Bang may not even make sense, because time itself had no before. Nothingness, in the deepest sense, may mean not only the absence of matter, but the absence of space and time themselves. And from that absence, from that silence, the universe bloomed. Of course, beyond the physics lies philosophy. Why is there something rather than nothing? Are the laws of physics enough to explain existence? Or do they themselves require explanation? Is true nothingness possible at all? Or is existence the only reality? These questions remind us that mystery is not only in the stars, but in our own minds, in the way we wrestle with questions larger than ourselves. To live is to wonder, and to wonder is to step into the deepest tradition of human thought. And so we arrived at mystery itself, not as a problem, but as a comfort. The unknown is not a void to be feared, but a source of peace, a reminder that we are held within something larger than our comprehension. Just as the stars shine, whether or not we understand them, the universe exists, whether or not we can explain it. To embrace mystery is to accept that not every answer needs to be found, that the beauty of existence often lies in the questions themselves. As you rest now, let these thoughts drift through you like a quiet tide. The universe is vast, its origins mysterious, its truths deep, but you are part of it. You are woven from the same fabric as the stars, shaped by the same laws, balanced in the same harmony. The fact that you exist at all is already part of the wonder. Nothingness may or may not explode into energy, but tonight, as you breathe, you are proof that something does exist, and that is a mystery worth cherishing.